Hey guys, I'm back. Sorry I was having a problem, but Hypercam 2 just felt like glitching on me, and I guess my mouse is still glitching on me. I don't know. Hopefully, it just kept like stopping in the middle. So hopefully I'm gonna be able to, just use it. I uninstalled it and re-downloaded it. Anyway, that's none of your business. Today I'm gonna be explaining blink without delay, the Arduino code. Now, I'm sure you've all made an LED blink with an Arduino. If you haven't, go do it right now. There's this regular blink code. And the way the regular blink code is, it says turn the LED on, wait some amount of time, turn it off, wait some amount of time, and go back to the beginning and turn it on again, and so on and so on in this loop. Now that's fine, but the delay function, which you may not know or may know, delays the entire microcontroller. So if you have serial communication going on, that's going to get delayed. If you have reading a sensor, like an analog or digital input, that's going to get delayed as well. If you're sending out serial information to the computer, that's going to get delayed as well. It delays everything. So that may not be the best choice for you. So this code right here, I'm sure you've all seen it and used it. If you haven't, go use it. It blinks without using a delay. Now, I'm sure plenty of you are happy to just, this is what most Arduino users do. I know there's a select few that actually learn to understand the code. But what they do is they just say this, they say, all right, delete that, and they just paste in some code they found on the internet or they made up themselves. Good for them, right? That's what most people don't even write code themselves. Anyways, they put it here, and then they have an LED blinking at the same time, and that's great for them. I'm making the thumbs up sign right in front of the microphone, but you couldn't see it if you wanted to. So I'm going to show you actually how this code works so you can use it in your own code without and so you can seem competent and like you know what you're doing, which is impressive and pretty much mandatory if you want to write your own code. So we start out constant integer LED pin 13, just means the LED is on pin 13 and it is constant. It will never be on something else. Never on pin 14 or 12, always on 13. You couldn't change this integer if you wanted to. Then we say the LED state is low, meaning automatically the LED is off. 0 volts. The Arduino is going to just put ground on the pin, and since ground, connecting the ground to an LED does nothing, you got nothing. Then you have a long variable type, which is just essentially, if we go to Google here, never mind. I thought I had that page pulled up. Anyway, it's just simply a 4 byte thing that's used to store numbers, negatives and positives. So, that you have this number here, and it's called previous millis, and it's just set as 0. Now you have this long, again, another long, it's just used to store numbers. The interval, and that's set to 1,000. So this is the interval at which to blink the LED in milliseconds. 1,000 milliseconds is a second. So you can change that just like you could change the delay function in normal Arduino code. Now we know the LED is going to be an output, simple enough. So then in a loop, you have the unassigned long, which is essentially a long, except longs handle negative numbers. Unassigned longs don't handle negative numbers, but they can handle higher positive numbers. So, a very high number at that. The reason you have to use an unassigned long here is because this millis outputs an unassigned long. I'll explain this all. I'm sure it's making no sense right now, but I'll get to it. So you set essentially an unassigned long, you just think of it as any variable. You can't use integer math functions. You cannot use regular integer math functions. It won't work, just saying. So they've said this unassigned long thing called current millis. So they've just made up something called, which is this thing called current millis, which is an unassigned long, is equal to this function in the Arduino code called millis. This isn't a custom function. If you look down there, there's no void millis or whatever. Millis is actually Arduino. The Arduino counts the milliseconds ever since the code started. So this millis is going to output you however many milliseconds it's been since you turned the thing on, and it's going to output it in an unassigned long format, which this code is calling current millis. So however many milliseconds that it's been since the Arduino started up is current millis. If however many seconds that it's if the millis, however many milliseconds it's been since the code turned on, minus the previous millis, which you can see down here is set afterwards. Anyway, if this is less than the previous millis, which we've set as 0, if that times that is less than the interval, as in if it's if it's time to blink the LED. Like, you can just see the thing counting to 1,000. So say your current millis was 500 minus the previous millis, which is automatically set as 0, right? You know, so it's been 500 milliseconds since the Arduino turned on, and 0 was the previous milliseconds, as you've seen at the top. This is the first time the code's running through. 500 minus 0 is just going to be 500. If that's greater than the interval, which isn't because the interval's 1,000, then the previous millis would be equal to the current millis. So, then if the LED is off, turn it on, otherwise turn it off. And then it would say, then digital write, then make the LED this state that's been set, either on or off. Otherwise, if this statement isn't true, then just do it again, and then current millis would be updated to whatever the new millisecond value is, and try it again. So if it was, say it was 1,200, which would be more than the interval, right? 1,200 minus 1,000 is going to be 200. That's greater than the interval, meaning it's time to blink the LED. It's more than time to blink the LED. So what this thing would do, it would then say the previous millis equals to the current millis. So that way you update the code. So that means that it'll never wait more than your interval time. And then it would set the LED to the opposite state that is now, which is what blinking is, and then it would write the LED to that state. So I hope you understand the way this works, that I've helped you to understand. Essentially the way it works is it counts the milliseconds has been since the code turned on. If those milliseconds minus 0 is greater than however many milliseconds you want the blink rate to be, then you basically flip the LED state using this code, and you set the previous, you set it from 0 to be the current value. Now that is very important, because otherwise it will always be greater than always be greater than the interval, because it'll always be minus 0. If you have it be minus whatever it just was, it'll update the code so it doesn't need to do 1,000. As in, if you have it as 1,001, which is what's going to happen, it's always going to be at 1,001 because it never misses a millisecond. Your Arduino will never miss a millisecond. So if 1,001 minus 1,000 is 1, or sorry, 1,001 minus 0 is going to be 1, or 1,001 is greater than the interval 1,000. Then it's going to set the previous millis equal to 1,001. So then, if the current millis is 1,002, if that didn't happen, it would then also flip it. So you just have the LED flipping on and off every time this code is ran through, which is 8 million times a second or something crazy like that. So that means that your LED would just look to you like it was half brightness. You don't want that. Now, say you included this code, which you should, unless you just want failure. Then, if the code was 1,002 minus 1,001, that's just 1. That's not greater than 1,000. It's going to have to wait till it gets to 1,000, till it gets to 2001.001 or whatever, right? Then it will do the same thing. So that's the way it works. Let's put it in a nutshell. It does all the variable stuff. You set this interval, and you set some values, previous millis. You then count how many milliseconds has been since the code turned on. You store it as a value. If the value minus however many it's been since you last changed the LED, so however many milliseconds it's been since you turned on the program, minus the milliseconds it's been since you last changed the LED, if that is greater than some set amount of time, the time you want it to be between blinks of the LED, then what you would do is you would update the time. So you would then flip the LED. So if the LED is on, make it off. If the LED is off, make it on. And then what you would do, I mean, this isn't the right order, but this is the way your brain would logically think of it. I'm trying to make it easier for you. Then what you do is, since you just updated the LED, right, since you just flipped the state, you would then update the update. So the previous millis says it was last updated now. So you make it so it says that since the previous millis, you can think of previous millis as the last time the LED was updated. Since you've just updated the LED, you want to make the previous millis reflect that, so you make it the current time, because the current time is the time when it was just updated. And that's it, really, and then it just does again. So, thanks for watching, and I hope you understand that. Bye.